There are four major ways to classify the monosaccharides. In this video, we're going to talk about the first two. The first classification system that we have is by number. Here we're going to look at the number of carbons. The general formula of the monosaccharide is CH2O subscript N, where N is something like a 3, 4, 5, or 6. So if it has 3 carbons, we're going to call that a triose. 4 carbons, we'll call it tetrose. 5 carbon would be pentose, and hexose is going to be a 6-carbon monosaccharide. So the formula for a triose is CH2O subscript 3, which becomes C3H6O3. A tetrose would be CH2O subscript 4, that would become C4H8O4. And a pentose would be CH2O subscript 5, where we would have C5H10O5, and a hexose would normally be CH2O subscript 6, and now it'll be written as C6H12O6. The second classification system that we look at is by the functional group that's present. So all of the monosaccharides have lots and lots of alcohols on them, but on each one there is either an aldehyde or a ketone, which makes it into the monosaccharide, having lots of OHs plus the aldehyde or ketone. So we're going to identify which one it has. If it has an aldose, remember aldehydes are always on the carbon number 1, and so what you'll see is a carbon with a C double bond O and an H attached to that same carbon. Our second one is a ketose. A ketose is a group that has a ketone, and remember a ketone is somewhere in the middle of the chain, and in this case it's always going to be on carbon number 2, the second carbon down, but it's going to have a carbon with a C double bond O and a carbon on each side of that C double bond O carbon. Recall that when we're numbering in organic chemistry, aldehydes always get number 1 because they are on the end. And so we're going to be using that when we're numbering these monosaccharides. We're going to say that number 1 is where the aldehyde is, and then going down from there it'll be 2, 3, 4. In this case, this tetrose has 4 carbons. It is an aldehyde. The second one, we're going to look at how we number that. We want to give the ketone the lowest number we can. It's not going to be number 1, and in this case it would be number 2 because that's the lowest number it can get. And in all cases, our aldoses will be on carbon 1, and our ketoses for the monosaccharides will be on number 2. That is not true in organic chemistry, but when we're looking at the monosaccharides, the ketone is always on position 2. So it's very easy to tell the difference between the aldose and the ketose. You just look for the double bond and decide, is it on the top carbon? Well, then it's an aldose. If it's on the second carbon, it's a ketose. So again, we look at 2 different factors. The first is the number of carbons. So here we see 3 carbons in C3H6O. That makes it a triose. 4 carbons as a tetrose, 5 is a pentose, and 6 is a hexose. And our second classification looks at whether we have an aldose or a ketose. And if it's an aldose, that means the C double bond O is on carbon number 1 at the top. If it's a ketose, it's on carbon number 2, which is the second carbon down. Commonly, we could put these together to classify that, and the name of that class will actually have a blend of how many carbons and which functional group is present. So here we see the aldoses. The first one has 3 carbons, so we call it an aldotriose. Labeling each part, aldo means that it's got an aldehyde group, tri means it's a 3-carbon chain, and the ose is telling us that there is a bunch of OHs on each of the carbons, making it into a monosaccharide. On this side we see a ketose, but it still has 3 carbons. So this is a ketotriose. It's got a ketone, it's 3 carbons, and everything else has an OH on it. Then we look at the next one where we see an aldotetrose. Aldo means it has an aldehyde, tet means 4 carbons, ose means OH on all of the other carbons. And the next one we look at, we have a ketotetrose. That ketotetrose should have 4 carbons. OH is on all of the carbons except carbon number 2, which is going to have a C double bond O. aldopentose. Aldose starts with an aldose, which means we have a C double bond O at the top. Then we're going to have 5 carbons total. 4 of them will have OHs. Next we have another pentose, and this one is a ketopentose. So we're going to have 5 carbons long because it's a pentose. On the second one we're going to have a ketone, so a C double bond O there. All of the other ones will have 1 OH. And then we have an aldohexose, again 6 carbons. This is an aldose, so there's a C double bond O on the top carbon. All of the other ones have OHs on them, and then we fill out the H's. And finally our ketohexose, which says that we have 6 carbons, which are a 6-carbon chain. On carbon number 2, we're going to put a C double bond O for the ketone part of it, and then we put OHs on all of the other carbons, and finally attach those last H's, and we'll have the structure of a ketohexose. Now we're going to practice a little bit. I want to have you identify different ones as aldoses and ketoses, and then triose, tetrose, pentose, hexose, and put it together to give that classification of something, let's say like an aldopentose or a ketotetrose. So I'm going to have you classify all of these as we go through them. I'm going to be pulling them up on screen one at a time, and I want you to try to answer it while I have it up, and I'll give you a moment or two to answer it, and then I'll tell you the answer immediately. I will not be pausing the video. So what do we see here? First you want to identify the class of compound that you have. And in this case we have an aldehyde, so it's an aldose. And the second thing you want to do is count the total number of carbons, which we will see there is 1, 2, 3, 4, 5. 5 carbons. That makes this a pentose. And we put those two names together and it becomes aldopentose. And that's the way that we classify this. So what is this one? Start with the class. And what you should see is that this is an aldose. And then the number of carbons tells us a second part. And we see we have 1, 2, 3, 4, 5, 6 carbons, and that makes this a hexose. Put those two parts together, an aldose and a hexose, and this becomes an aldohexose. Here's our next one. You should be able to see that it is a ketose. It's got 1, 2, 3, 4, 5, 6 total carbons, so this is a ketohexose. And on this one we see another ketose, and then we've got 1, 2, 3, 4, 5 carbons, so it is a ketopentose. Alright, so let's try this one. I see it as a ketone, so it's a ketose. It's got 1, 2, 3, 4 carbons, so it's a tetrose. We put that together and you get a ketotetrose. And on this one, what kind of class do we see? Correct, it's a ketone, so this becomes a ketose. There are 3 carbons, 1, 2, 3, and that makes this a ketotriose. Alright, let's try this one. First, we see it's an aldose. There are 3 carbons. This is an aldotriose. Alright, let's try this one. You should see that it is an aldose and that it has 4 carbons. So this is an aldotetrose. Now I'm going to have you try to draw some of these. Let's try an aldopentose. Go ahead and pause the video while you draw it. And in this case, we're going to start by drawing our 5 carbons. We're going to put all the bonds around it. And we said it was an aldopentose, so we're going to make the top one into an aldehyde, put an OH on each of the other carbons, and then fill out the rest of the bonds with hydrogens. Next, let's try a ketohexose. Go ahead and pause the video while you draw it. We'll start with the fact that there are 6 carbons since it is a hexose. And then on carbon number 2, we're going to put in our C double bond O, our ketone. And then all of the other carbons will get at least 1 OH. And then we fill out the rest of it with hydrogens.